Hello, and welcome to our first episode of the GeoJournal Club. In this podcast, we will be analyzing papers that I received or I found on the internet, subjects that are close to me as a geochemist and economic geologist, and I think my readers will benefit a lot by reading these summaries. So, the objective of this club is to summarize the information of these papers that sometimes they are not even papers, they are videos from conference and webinars, and they are more difficult to get access to. So, in this first episode, I will explain a little bit how I do this, and we will be talking about this paper, the identification of geochemical anomalies based on RPCA and multifractal theory. It's a paper from Mongolia. Now, as you will see, each slide will treat a part or a subject of this paper. And in order to do this, I usually use a combination of two artificial intelligence software that you can find and get for free. The first one will be SciSpace. SciSpace is a wonderful software that will allow you to interrogate any paper or even videos and get the basic information from it. So, for example, in this case, if I go to my library, you will see here the paper, and I already asked several questions about this paper. And if you click here, these are some of the main standard questions that you can ask the paper, like explain the abstract, what are the related papers, explain the practical application, talk about the literature, the method, what are the main results, etc., etc. Even you can get explanations about math. If you get a formula, whatever it is, for example, I don't know, this one here, you can ask for an explanation of that formula, and also you can explain a table, and it will tell you here what is the formula about, etc., etc. Now, this is a very dedicated software, let's say Space, but you can also get the same results by using ChatGPT or Perplexity. In Perplexity, for example, here I just uploaded the whole paper as a PDF. It will read PDF, Word, etc. And I can ask a question like this: what is the main takeaway points of this paper? And both of them will give you different informations. Okay, in the case of the size space, it will be more related to the content of the deposit of the paper. In the case of perplexity, it will go outside of this. For example, one thing that I find very useful in this paper, they use four statistical methods. Very important that they use compositional data analysis. So they have the ILR method, their principal component analysis, but they also have other methods like the singularity based analysis or method, Fry analysis, etc., which are less common. Well, you can ask, please explain me how to use the robust principal component analysis, and it will give you an explanation. Same thing, for example, explain the singularity based essay method, and it will give you an explanation of how to use it. So a combination of these two methods will allow you to extract all the information that you need from your paper. So let's go back and let's talk now about the summary. One thing I need to mention here, that this paper, like many papers that are related to the academy and not to the industry, they miss one very important moment in their study. And this moment is precisely the use of quality control samples. So basically, they do very, very advanced analysis. They compile data from multiple sources, but regrettably, since they didn't use quality controls like standards, duplicates, blanks, etc., we cannot validate this data. It doesn't mean that they are wrong, but it means that we cannot validate it. And since we cannot validate it, then we cannot accept their conclusions and recommendations blindfolded. So this is something that is very common in the academy, sometimes because they have limited resources, little money, so they cannot increase the amount of sample by adding standards and duplicate, but they need to do that because, as I said, a data set that is not validated cannot be used to do any kind of conclusions or recommendations. It's always going to be weak. So I hope that academia will understand this soon and they will start using the quality controls parameters. I'm going to put a link here to another video where I talk about quality assurance and quality control. So as I said, you can browse this presentation. Here is the summary. I'm not going to read it. You can read it yourself. Then we have an introduction. And one of the things that you can do when you're using SciSpace or even Perplexity, you can copy images and you can analyze these images. So this is the introduction from the paper. This is a sampling that was compiled from Mongolia. Then there is the explanation of the different methods. One thing that this paper is really good at is that they use the correct compositional data analysis. Again, I will put another link somewhere down there with a video about why and how should geologists use compositional data analysis, which is a branch of statistics that must be taught even at the university level, and I hope at some point it will be done like that. But also, it's very nice to know that in the last 5 years, the amount of papers that have been citing the use of compositional data analysis has increased exponentially. So this is good. As I said, they use the compositional data analysis, the principal component analysis. They call it robust, but it's a normal compositional analysis that you do with compositional data analysis. There is a program, it's called Coda Pack, which I also going to put a link. It's a free software written in R that you can use to process your data and get the same results. And as I say, the Frye analysis method and the spectrum area fractal model, which are more specific to this paper, you can use Perplexity to get an explanation about how do they work and use it in your own data. One thing that I always find lacking in academic papers, and it's not the fault of the authors, is the restrictions imposed by the academic world. It's very rare that you can get a paper from the academy and just open it and say, okay, I'm going to use my data. Let me follow the example, because they are not examples. They are just, maybe they will show you the original data, which in this case is not there, and then they show you the results, but no explanation about how you get to this result. And again, it's understandable, because if you're going to put all this, then the paper will be too big. They will not sound very scientific, which I don't care. I work in the industry. I would prefer to have a step-by-step description of how I can use this method in with my data. So this is a weakness of all papers that we will be looking for in academia. Sometimes they put the original data as a addendum, as a document that you can download. But again, the step-by-step explanation of how you get from your data to these results are lacking. And again, this is not something, compositional data analysis is not something that is well known. This is a branch of the statistic that has very little knowledge. There are maybe 10 years ago, 15 years ago, it started to being used. And there are no many texts explaining this thing. The compositional data analysis is a graphical statistics, not a numerical one. So they are numbers, of course, but they base all the interpretation in graphics. For example, if you have an almost 90-degree angle between two elements, like I think it's arsenicum and silver here, that means that they have a strong correlation, close to one. We don't know if it is positive or negative, but it's a very strong correlation. If two elements are almost collinears, that means that they don't have any correlations. Elements that are bunched together like this, they all have the similar information. So you may use only one of the three and you will get the same information as if you were using three of them. And the other point here is that the longest axis means these are the most important informative elements. So you will want to use the longer axis of elements to decide who's the one that have the most information. So method, process, and represent these graphics. I always recommend Surfer from Golden Software. It's one of the most capable methods for representing geochemical data, and especially because it includes very powerful variogram method to pre-process your data before presenting it. When I read this paper, I don't think they use the variograms, which again is not good because variogram will tell you the anisotropy, the orientation of the data. If there is like a trend, the virogram will find it. And if you do the grading, taking into consideration the virogram, it will show those trends. So it is important to use the virogram. So I'm giving you time here to read these main results. Again, you can stop the video and read at your own pace. I did like the application of these rows diagrams to interpret the data. Regrettably, again, it is not explained in detail how they got to these rows diagrams. As you know, the rows diagram have a specific way of being interpreted. But at least we can now, at least I will be doing a little bit more research on the SA method, okay, and the fry analysis with my own data, playing around a little bit and see what can I get. So what are the implications? The most important implication here is that the authors use compositional data analysis, and it is very nice that this method, which is extremely important, is getting to be used more and more frequently in even in the academic literature. And it also mentioned the powerful principal component analysis, which requires the method itself is a very interesting method, very powerful method. It groups the different elements in accordance to association between them, but then you need to interpret that. You need to know geology. You need to understand the geochemical process in order to be able to use the principal component analysis as an effective tool. My main limitations is the absence of a quality control, which renders the database not validated. That is the main thing. The fact that they are only focusing in an area of Mongolia, well, that's the area that they use for this study. This is not a limitation. You cannot use the whole world to do a paper. And they mentioned that third methodology was not very well explained, especially the Fry method and the S2A method of processing. But again, the important point here is that they are mentioning these methods, and you can on your own learn a little bit more about them, see how they work, use your own data, and learn how to use these statistical methods in your area of work. And future work, they are planning on expanding the normal thing. Again, for me, if I could advise the authors, the main future work must be to introduce standards, duplicates, and blank in their data in order to validate it. It's important. Without validation of data, all these conclusions and recommendations, they are on a very weak base because we are not sure and we cannot be sure that the data is correct. They don't even mention which labs did they use. Usually there are several labs that have very good standard like ACT Lab, SGS, and others. Doesn't mean that you can rely only on the quality control of those labs, but at least you know the information. Where did they do this test? Did they use a lab at the university or a local Mongolian little lab? There is no information about that, and they should always use ISO certified laboratory. So that's it. This is the first paper that I wanted to discuss and show to you. I hope this format will be interesting. Let's chat, ask some questions after down there in the comments, and I will be processing other videos and other papers in the near future. Thank you very much, and I'll see you in the next club presentation. Have a nice day.